Hello and welcome to another edition of Momentum. I'm your host, John Mercado. My first guest today is Dr. Mark Horstemeyer, CAVS Chair Professor in the College of Engineering, in the Department of Mechanical Engineering, and the Bagley College of Engineering at Mississippi State. Mark, thanks for being with us today.
Good to be here, John.
And you have a lot that you can talk about, but I think we're starting with bioinspiration based on the visual aid you brought.
Yeah, I did. Let me just start by saying I first came here, I didn't have an idea about this at all, really. And it was in the process of doing our car work at CAVS that I started thinking about the engineering of the car and the history that went on in that, and a lot of things were carried on in history. So I started thinking about, what new ideas can we bring in? And so I just started studying things in nature. As a Christian, I believe God made everything. And I thought, okay, if he's a great engineer, how could I understand his ways of how he made things? So I started thinking that. And one of the things was this fossil here. And you can see in here, there's these lines that go up and down, the wiggles right there. Mm-hmm. Those are called sutures. And you see there's a big one, and there's a little one on top, and a little one on top all the way through. What you find out in nature, anytime there is an animal that experiences a shock of some sort, a woodpecker, a ram like this in this ram's horn here, this kind of seashell, anything, turtle shells, armadillo shells, there's always these sutures. And we have them in our skull. And what they do is they will take a normal wave and make it into shearing. Shearing dissipates energy. So then it's taking that idea and put it into bumpers. Put it into side doors of cars. And what you find is in our cars, in our vans, trucks, we don't have things like this, but yet it's ubiquitous in nature. It's everywhere. So that's one of the ideas here. Another idea is the curvature of this. And you see this curvature going from really thick to really thin, and it goes in like this. It's exactly a Fibonacci sequence. I don't know if you know what Fibonacci is. You take 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8, and you go on and on. When you take the highest number divided by the next one, it's always 1.6, always. And when you put a 1, a 2, a 3, and you start going through this curvature, you find it's a Fibonacci sequence. This guy lived around 1000 AD, and you find it in nature as well. But usually it's a law of beauty people relate to. Like Einstein, for example, went into physics because of the Fibonacci sequence, actually. If you find out Beethoven's Fifth Symphony, it was all in Fibonacci sequences. Okay, so it's sound, beauty. Look, I've tried to find out if it's related to strength. And recently we have found that out. It's even in things like the ram's horns. And this is a perfect Fibonacci sequence as it goes through here. And in the ram's horn, you find the sutures that are real small. You can't even see them. But at this large scale, it's you hear the resonant frequency in that wave. And that curvature, it makes that wave transfer that way. And when it's first hit, it starts out what's called a normal wave, and it goes all the way back, turns into shearing. The same thing that happens here. And again, it's how we want to dissipate things. So we're seeing this ubiquitous idea in nature, things that you wouldn't say is related at all, a ram's horn and this kind of thing, but yet they're there. It's because of common engineer,
right,
that made it all.
Right. So
we're bringing these ideas into, the automotive world, trying to bring them into the helmet world, whether it's football helmets, baseball helmets, even soccer helmets. We had a design team last semester, mechanical engineering, trying to implement some of these ideas. So we had 3 teams, a soccer helmet team, a hockey helmet team, and a baseball helmet team.
And I think some of that research has to do with concussions, right? So you're kind of using that in terms of concussion research. Can you talk about that a little bit more? Yeah.
So the idea is how to protect the human with this structure outside. So with this, ammonoid here, the animal's inside, and how to protect it with this shell. You want to protect the ram's horns or the ram's brain. So you're using the horn. So in the car, of course, design the car for the human. You may be surprised, but cars aren't designed for humans. They're designed for dummies. Right. But the same thing, okay, then that's when I had the thought about football helmets. How do you protect the brain, and how do you design something outside, with that to protect the brain from concussions? So right now, concussions are, not, they aren't, football helmets are not being designed for concussions, right?
Right, right.
So
And your research can help maybe make a change.
that's the
sort of
idea for
paradigm
that kind of
shift in
thing.
that way. Yeah.
Yeah.
What about outside of football? What about any sort of commercial or more widespread applications? Are there things that can be used for outside of that?
Yeah, we're doing related to this, even like, well, from shoulder pads to mats, for taekwondo or karate or things like this. How do you make mats to mitigate from the shock wave?
Right.
But even beyond that this is a megalodon tooth here, John, and this is only 4.5 inches. I say only 4.5 inches because the biggest one was 7.5 inches, and that was estimated to be 75 feet long.
Wow.
So this was only about 40 feet long. But if you look at the serrations on the edge, you can imagine. So we're also doing like studies of different sharks and their mechanisms for tearing and ripping.
Right.
And the idea is, could we come up with a new knife or a new cutting mechanism through structures,
Right.
From an engineering perspective.
Wow. Well, Mark, this has been great. Thank you very much for joining us today.
Oh, my pleasure.
We'll be right back after the short break to talk with Tamara Swan from the Bagley College's distance education program.